transformation, not just here, but globally. He's a data architect at ABN AMRO, a storyteller, and co-founder of the Digital Natives of Aruba Foundation. Presenting his keynote, Small Island, Big Intelligence, 100 Years of AI and the Rise of a Digital Aruba, please welcome Mr. Haime Croeze.
Good morning. 100 years of innovation has taught us one thing. We are getting closer not to machines, but to ourselves. So as we say in Aruba, bon dia. When I got the invitation for this event, many thoughts crossed my mind. First of all, it's an honor to be presenting this for you. Second, all my presentations are in Dutch, so this is English. Bear with me. Sorry. Of course, it's happy to be home, visit family and friends. But more importantly, inspiring the future, I got two thoughts. I thought to know the future, we should reminisce on the past. We should talk about the past. So 100 years of artificial intelligence is the theme I chose. Yes, 100 years. And this is a wonderful opportunity to tell you more about the foundation that we have for a couple of years now, called Digital Natives of Aruba. And the vision that we have for a digital Aruba. For those of you who don't know us, Digital Natives of Aruba started a couple of years ago, where we noticed, we were 6 co-founders, or 7. Giorgino is one of them, the previous speaker, where we noticed that digital solutions that are needed to bring value to Aruba were being lifted and shifted into the Aruban marketplace without regard to the Aruban culture, context, etc. And as professionals in IT and data working abroad, but more importantly, born and raised Arubans, at least we thought we are the preferred candidate to make this translation. So that's what we do. And I want to connect this 100 years of artificial intelligence with the vision that we have for the future. To make it easy, I made it into 4 eras. And starting with imagination, at some point we imagined artificial intelligence or intelligence as such. Then we went into an era of understanding. With science, we try to comprehend what intelligence is about. At some point, when you have enough theory, you need to go into practical solutions. So we started applying intelligence. And at the moment, we are in an era of creation, where intelligence is not only being applied, but it's creating its own content and surrounding. So allow me to move through these 4 eras with you. The first one, imagination. I have it set at 1925, but of course, the lady on the screen, her name is Mary Shelley, and maybe some of you know her book. When she was 19, in 1881, she wrote a book called Frankenstein. And Frankenstein was the first AI novel where we imagined a creature that was human-like, and we lost control of it, of course. That's how it goes. Anyhow, it's about dreams that we had, imagination, and how we could build those machines. First of all, in 1925, 1927, there was a film, a movie, sorry, where we went from the books of Frankenstein to the movies, called Metropolis. That's the first movie where a robot appeared. It was based on a play called Reur, but anyhow, this was the first one. And the appearance of this robot, it's a she, it's a Maschinenmensch, it's called, but her name was Maria. And her appearance, you can see, who knows Star Wars, Tricipio? Looks a lot like, eh? The Oscar, maybe? But Maria was the first. And robot comes from a Czech word, and the Czech word is robota. And robota means to toil or hard work, hard labor. Farmers and peasants in Czech are called robotniks. So just to know. So in this movie, there is a famous or important line that basically says that we can build these robots with our minds and with our hands, but we can only guide them with our hearts. So this makes 100 years ago already those science fiction writers thinking about human. So, for instance, if we have a robot, the question is not, can we make this robot human-like, but how do we stay humane when we build those robots? Of course, as soon as you have a robot and many more, regulation must follow, because you can't just have robots. You need to have laws. And there's a writer in 1940s, Isaac Asimov, who came up with the 3 laws of robotics. These 3 laws that you see on stage are still applicable today, are still the basis of AI ethics, are still what we follow. And there has also been philosophical debates about the order, and the order is as it's 1, 2, 3, and it has to be this way. If you change the order, you will get Armageddon. So Asimov gave us basically he encoded the morality which Metropolis guided with the heart. Then we leave this imagination era, we come into the understanding. Understanding is about science. The man you see here on screen, he's my personal hero. His name is Claude Shannon. For those of you who don't know, he invented the bit, or the science of the bit. His theory is called information theory, and he was the first one that came up with a theory how we can encode, structure information. And it's the basis of everything we do with computers, from my point of view. But science is the start where we went from imagination to understanding. For understanding, there is one person that's particularly important in this field, or one field that is important, and it's called cybernetics. Norbert Wiener is the father of cybernetics. And cybernetics didn't take up the question from how do we think, but what is thinking? How do you adapt? How do you become intelligent? By adapting. And his proposal was very simple. You sense, you act, you compare, you correct. Think of, and that's true for machines and for animals and also humans like us. Think of it as a thermostat. We can maintain the temperature of 21 degrees because this thermostat senses, acts, compares, and corrects. If I'm walking and I'm trying not to stumble, that's because I sense and correct so not to fall. And this cybernetics has a huge impact still nowadays. When this book came out, this theory came out, they already started thinking about neural networks. This is something that we're doing now. At that time, they were thinking about neural networks. The information theory of Claude Shannon was based on cybernetics. Machine learning, the act of machines learning is based on the adaptation theory of cybernetics. There is a whole field of systems thinking, system design with Stafford Beer and people like that are out of cybernetics. So a very important person in that regard. The next one that's worth of mention is Alan Turing. I think most of us would know the Turing test. His question was, can we imagine interaction whereby an entity, human or robot, can interact with us in such a way that we cannot make a difference. We don't know if we're talking to a robot or to a human. And that's a scientific test. So if they talk today about artificial general intelligence or whatever, this is the test they apply. As an irony twist, every day all of us, millions of us around the world, are doing a Turing test, but it's a reverse Turing test. The CAPTCHA that you do on the website, I'm not a robot, it's a reverse because it's not us human asking if the robot is a human, but the machine is asking us to prove that we are human. And some fail. So, when did up till then, the word artificial intelligence was not a word, it was not a field at least. There was a conference in 1956 in Dartmouth where a lot of scientists came together. And at this conference, my hero is there, Claude Shannon on the left with the glasses. That's John McCarthy. John McCarthy is the person that organized this event, and he's the person that came up with the name artificial intelligence. And their question was also pretty simple. Every aspect of learning or intelligence can be so precisely described that a machine can be made to simulate it. We know that we're still not there, but at least that's the basis of all the things we do in artificial intelligence. Then we leave the understanding. There are much more, but because of time. Let's go into the practical solutions. Because at some point, as is with science, they get into ivory towers, it's called, and theories, and nothing practical comes out. So at some point, funding dries up, but it made an opportunity to change artificial intelligence from a theory to a practical usage. The woman you see here, the lady, is also a very important one. This is Karen Spark-Jones. And Karen Spark-Jones came up with a method to make information searchable. It's term frequency, document frequency, but anyhow, without her, there is no Google search, there is no Bing search. We would be meandering in tons of data without being able to extract the information we're looking for. Another famous quote of her is, "Computing is too important to leave it to man." So, yeah. But as I said, this practical era started with what we call an AI winter. The funding dried up. DARPA was funding a lot of the AI theorists, but as results stayed out, they stopped funding. In the UK, you have the Lighthill report that basically said, nah, let's stop with this. This is a moment in time for from an academic perspective, but from a practical perspective, this opened the gateway to practical use, to applying artificial intelligence or intelligence as such. The first appearance of this is with expert systems. An expert system is, as the name says, you take an expert, a doctor, a physician, engineer, a financial analyst, a banker, and you extract the knowledge, but you extract it as rules. So if patient has symptoms X and Y, the diagnosis should be that he or she is suffering from Z. And these systems were pretty much huge and used a lot. They're called rule-based systems. They're not your high-end AI, but it has encapsulated intelligence, knowledge. And for instance, my SIN was one that was trained specifically for diagnosing bacterial infections, if I'm not mistaken. And they were consistently better than the average physician. So that wouldn't say much about the system, maybe a lot about physicians, but they were consistent and they could they guided the physician with the diagnosis. At some point, we noticed that the reality is much more complex than just these rules that we can program. Why not let the data speak for itself? Also, helping the human to make decisions. This is the application of analytics, data warehousing, the start of business intelligence, where we started to gather this data, aggregate, transform, present it in such a way that someone can take a decision based on evidence. Before this, it was based on gut feeling, experience, hierarchy, and now we started getting into this data-driven approach for decisions. Mind you, it's not the machine taking the decision, it's a decision support. It's providing the information. And with this, I want to conclude the application era. because then we get to the current period, creation, creating. Another human, a man. Does somebody know this Dutch guy? This is Guido van Rossum. And Guido van Rossum is important because he came up with a programming language that's called Python. And without Python, basically Python democratized artificial intelligence for everyone. Every student, every researcher. It's a simple language, and it made artificial intelligence accessible. Without Python, we wouldn't have this boom, I think. And it's all due to his work. From the analytics and data warehousing, what you see in the creating is three forces came together. First of all, cloud. Cloud meant that we can go from those hardwares somewhere in the closet to, let's say, infinite computing power. Big data meant that more and more data was fed into the machines, not only transactional data, but events, signals, everything. And machine learning. And machine learning is important because before machine learning, and think of the rule-based, we told the machine how to perform a task. With machine learning, we're feeding the machine with examples. The machine will find patterns, learn itself, and perform the task. So this is a huge change from the previous. This is where machines started creating. So then we get to the current, and this is something that all of us know, of course, generative AI. Who doesn't use ChatGPT, Midjourney, DALI? There is one called Cloud, and Cloud is, of course, based on Claude Shannon. Gen AI is, as the name said, generative AI. It produces content. So based on all the knowledge it has, all the data it has gathered, it can produce content. Is it artificial intelligence? I think it's a very smart linguist, but it's a huge step. The second one is more recent, agentic AI. Agentic AI means that it's an agent, think computer program, that can autonomously take a decision or perform actions within a context. I always have the example of aviation at Schiphol Group. The gate planning, so where the aircrafts are parked, it's a very complex planning. You have an agentic AI agent that can, within that context, decide that this flight or this aircraft needs to be placed there and there and there and there. But it's all smart within that context. It knows nothing about baggage, nothing about humans, passengers, and so only aircrafts and gates. So where Gen AI creates content, agentic AI creates actions. And that's why we call this the creation. So if we go back to the future is human, I hope I have shown you that the whole process we've gone through in these 100 years has not been per se about the technology, but about us being human and understanding more and more about ourselves, and that this era is finalizing, and you see this with something we call augmented collaboration. So these agents you see that they're building right now that can perform actions are there to, together with humans, and other agents to make complex decisions possible. And that's augmented collaboration. So if we talk about augmented collaboration, we think about also some of the problems of AI nowadays. They have a tendency to hallucinate. They have a tendency to have bias. And what you see is that there are some power blocks in the world, in the US, Asia, that are building everything. Also you see a push from global to local, sovereignty, AI sovereignty. We want to be in control of our data, we want to be in control of our own stuff. For an island like Aruba, sovereignty, it's a large ask. But what if this augmented collaboration means that we can be a regional bloc? Imagine that we take the Caribbean as a region of augmented collaboration, whereby it's a connected ecosystem. We have like a regional digital mesh. Each island is a node. And we can collaborate, learn, and create together. And the context is right, because somehow we're in the same ship, schuitje. We're in the same thing together here. And we can provide ourselves with the Caribbean narrative, but provide the world also with the correct narrative about us, instead of Europe telling the rest of the world what the Caribbean is about, or the US, or Asia, or whatever. So this is possible with the technology we have now. And we think also that in this collaborative mesh, Aruba can play a leadership role. And then comes the question, why Aruba? And what does it take to have a leadership role? Well, start with why Aruba? We have 4 strengths: education, language, connectivity, and hospitality. Maybe it doesn't seem much, but if you take those 4 strengths together, what you have is a culture of collaboration. We're built to collaborate. Multilingual. We talk many languages. My English is not, but I'm doing it. I can do Spanish, I can do Papiamento, I can do Dutch. But more importantly, we understand many cultures because we can speak with them. Education, we are not only educating our youth, our people, but we are connecting them to global universities, to other places. Connectivity. Okay, we have digital connectivity. I think it's okay. Connectivity can be better, but we have also physical connectivity. All of us have someone, know someone in other places of the world where we have a connection. And of course, hospitality. And hospitality, we also most of the time think of tourism, but hospitality is the willingness to make partnerships, the willingness to create a bond, the willingness to work together. So if we take all of these together, we are just ready to take a leadership role within the Caribbean for collaborative, augmented collaboration. Of course, this is a vision, and a vision without action, yeah, that's a pipe dream. So we got some actions for you. First of all, we need to invest. Invest in the people. And invest not only in education, what we are doing now, but invest in the future skills. And future skills, they are relevant now, but if you look at ethics, that's a very relevant one. Cybersecurity, very relevant. Digital savviness, those are the things we need to invest in. Build the infrastructure. Then we can think of connectivity to the internet, but also, why not the infrastructure legal, financial? If we're collaborating with many islands, we should be able to make transactions seamless or collaborate seamless with those islands. Empower our innovators. There are lots of entrepreneurs, students, whatever, who are coming up with new ideas, failing, trying again, failing, trying again, success. Empower them. Give them a stage. And last, lead by example. If we want to fulfill this vision of an augmented collaboration or Caribbean as an ecosystem, we need to show the way. We need to be the first one to collaborate, be the first one to connect, be the first one to show them how and what our vision is. So with that, I want to leave you with, let us not be witnesses to this future, let us be the authors. Go forward, be brilliant, lead the future. Dank je.